Okay, I wanted to make a quick review of Tuesday's class, so to help you answer the reflection questions that are due Thursday. We started out just introducing angles, and we defined what an angle is, and then we asked the question, what does it mean for two angles to have the same measure? And that was actually the first question on the worksheet number 1. But we said before that we need to really ask what characteristic of an angle we're assigning a value to when we measure it. And we said that was the openness of the rays. And we had this just little quick exercise assigning from least to greatest openness, and that was C as the least, then A, B has the greatest openness. So therefore the measure of the angle from least to greatest would be the same, C, A, B. Then we asked the question, how do we assign an actual value to the openness of an angle? Or in other words, what's the basis for measuring angles? And that took us to our pizza cutter activity, where you very successfully figured out that an angle is determined numerically by the portion of the circumference that it subtends, the angle's rays subtends if the angle's vertex is placed at the center of the circle. So from there we summarized your conclusion, or what you did in that activity, that an angle measures the percent or fraction of a full circular rotation, or it's the length of the circular arc relative to the length of the circumference. And so I just had 3 short examples here of how circles and this idea of relative arc length, or percent or fraction of a circle, is the basis for measuring angle. So this was our 25% or 1/4 angle. This was our 66 or 67% or 2/3 angle. And this was our 1/6 angle. From there we asked, okay, in light of this basis for measuring angle, then what is a degree? And we said it's basically 1 degree, a 1 degree angle. If its vertex is placed in the center of the circle, will subtend 1/360th of the circumference. And we define subtend as meaning cutting out a piece of arc length by its 2 rays. Okay, and then from there we moved to talking about radians. And so we looked at these 3 circles, and we showed that for each circle, if we peeled off that radius and laid it on the circle, so there's the radius 4 arc length, and then the radius 6 peeled off and laid on the circle. And then we asked the question, what's different and the same about all these? You came up with it, the arc length, the circle that they're on, and so the radius and circumference, and the color are all different here. What's the same? Well, the relative arc length to the circumference, and they all will they all mark off the same angle by the end of their arc length. So if we said this was the initial side of the angle, and we could have the terminal side of the angle would go through the ends of those arcs, and we called this angle measure 1 radian because it subtends 1 radius length, no matter what circle you choose. So this is 1 radian angle measure because it subtends 1 radius length. Likewise, two radius lengths, no matter what circle, will indicate the same angle, and that angle then will be a measure of 2 radians because it subtends 2 radius lengths. Then we ask the question, how about getting halfway around the circle? And we said the 3 is short, but 4 is way too much. So we said closer to the 3 than to 2. And so we could try 3.2. We see that 3.2 is too big. We could try 3.1. Too small, so we could try 3.15. 3.15 you see is just a little bit too much, so we could try 3.14. Well, now this looks pretty good, but you come over here and we zoom in a little bit. If you look close, it's still 3.14 is still a little bit too small. So we can try 3.141. Still a little bit too small. 3.1415 is now, you can't see that it's off. And we of course know that even closer than that is 3.1416 because the number of radius lengths to get halfway around the circle is pi radius lengths. So the number of radius lengths to get halfway around the circle is 3.1416 radius lengths, or the measure of the angle that subtends exactly half of the circle's radius is an angle measure of pi radians. Then for the last activity, I put it back at 3. So we put the number of radius lengths to 3, and then we made a table for each of the 3 colors. We looked at the radius of its circle and the arc length and the angle measure. And for each of the 3 circles, the purple, the blue, and the red arc length. And what we saw from that was this relationship that the number of radius lengths will be the total arc length divided by the length of one radius. And since that's number of radius lengths, it's the same as the radian measure of the angle. The point of that table was for you to see the relationship between angle, which is the same value as number of radius lengths, equaling to the arc length over r. So this is going to be a real important relationship for understanding radians. Okay, so that was where we finished, and now you've got an overview to answer those reflection questions, which are due Thursday. We will see you then.